So the very last thing that we're going to look at is dimensional analysis, okay, or factor label method. This is going to be your best friend as you work through AP problems. Okay, dimensional analysis is how you convert from one quantity to another. If you're not very good at it, practice now. Okay, get all the practice out of the way so that you're really good at it coming in. You can start off strong. Most commonly, dimensional analysis is going to use conversion factors. Okay, so it's just a ratio that equals 1. They're just different units, right? So inches to centimeters, maybe you want to use feet into yards. But what we do is we use the ratio, which lets us change units, and we want to get units to cancel and get a new unit. And so this is going to be the main way that we go through dimensional analysis. Right, so our given unit is on the top. We multiply by our conversion factor. You put the given on the bottom with the unit you're trying to get to on the top, and then your units cancel. If you remember, you may or may not have been shown the gift tag. Right, think about it, Christmas time. You get a present and it's to on the top, from on the bottom. Okay, so the unit you're trying to go to is on the top, the one you're going from is on the bottom. That allows your units to cancel. So for example, if we want to convert 8 meters to inches, always start with your given. Okay, given is 8 meters. What I always recommend doing is figuring out what conversion factors you need first, then you can put them in order. Okay, so you can go meters to centimeters, right? This is where the metric comes in, okay, with prefixes. And then centimeters to inch, right? So this is going to be a common conversion factor. If you don't know, you want to make sure that you know, right? You're going to find as we go through things, there's going to be a lot of things that we're going to use over and over again that you're just going to want to know. And so our meters start out on the top, then meters are on the bottom, then centimeters cancel, and we go to inches. Just a small check for understanding, when you convert units, how do you decide which part of the conversion factor is in numerator and which is in the denominator? So kind of think about this for a second. Try to answer it for yourself or write it down, and then check your answer. So in order to cancel units, okay, the conversion factor needs the unit being canceled on the bottom. Okay, so for example, if the unit centimeters starts in the numerator, then the conversion factor must have centimeters in the denominator. So you always want your units to be able to cancel. So here are 2 examples that I want you to try on your own. The first is to calculate your mass in grams. If 1 pound equals, this conversion factor isn't right, 453.6 grams. Okay, so I want you to calculate your mass in grams if this is the conversion factor. And then I want you to convert from 515 meters per second to miles per hour. So go through these 2, see if you can convert these, pause the video, work through them, and then come back, check your answers before you move on. Alright, so you can go through my work. I just assumed 150 pound person. You go through dimensional analysis, you're always multiplying across the top, dividing by what's on the bottom. Because our given had only 2 significant figures, my answer could only have 2 sig figs. Alright, so these conversion factors are considered exact numbers. So you're not going to worry about rounding your answers based on that. You always want to round your answers based on the given. So in the first one, it's your given mass, your given weight. If you wrote it out in 3 significant figures, maybe 151, then your answer could have had 3 significant figures instead. In number 2, okay, it's 515 meters per second. So the way that I started it is I put 515 meters for every 1 second on the bottom. Okay, so we have meters per second. What I did first is I started with seconds. I converted to minutes, then minutes to hours. So I had hours on the bottom, which is what I needed. Then I went from meters to kilometers, because I knew I needed kilometers in my conversion factor. Then kilometers to miles, and I had miles on the top. And then what I did is I looked at my given, and my given was 3 significant figures, so I had to round my answer to 3, which is 1,150. So again, a couple more examples. I want you to go through these again. Some of these are going to be a little bit more difficult. You're going to notice that the dimensional analysis problems that we're doing now are going to be much more complicated than the ones that you were used to last year. So go through these 2 examples and then come back, and take a look at your answers and follow along if necessary. So you can take a look at the first one, and we had to go from kilometers cubed to liters. And so a conversion factor that is helpful to know is that 1 liter equals 1 decimeter cubed. So what I did is I went from kilometers to meters cubed. So kilometers cubed to meters cubed. Always go to the base unit if you're not sure. However, notice because my units are cubed, my numbers have to be cubed, except for your given, right? This already takes into account the cubed. So if 1 kilometer is 1,000 meters, 1 kilometer cubed is 1,000 cubed meters cubed. Then going from meters cubed to decimeters cubed, you have to do the same thing. All right, so starting out here, we're using the metric system, then we're using the conversion that you guys already know with the liters to decimeters. So for the second problem, what is the mass of 1 gallon of water if 1 gallon is 3.79 liters, or 3.785, whichever we use. So you have to start out by going gallons to liters. Right, that's the conversion factor that you're given. The other thing that's going to be important to remember is this last conversion factor, which is how I get from volume to mass. Right? Whenever you're going mass to volume or volume to mass, you always use density. I start out by going gallons to liters, then I go liters to milliliters, okay? Because I know that eventually I'm going to have to work with the density. I go from gallons to liters, liters to milliliters, milliliters to grams. My answer already has 3 significant figures. That's what my given is in, so we're good in terms of sig figs. So again, here's another example in which we're taking everything one step further. Determine which of the following is the heaviest and which is the lightest. So we have a 5-pound bag of potatoes, a 5-kilogram bag of sugar, and 1 gallon of water. So the thing that's probably going to be the most helpful is if we take all of them and go to grams. Okay, that's the base unit that we work with, so let's do that. So we have 5 pounds of potatoes. So remember, 1 pound is 453.6 grams. Okay, so that's the potatoes. 5-kilogram bag of sugar. Well, now we know that 1 kilogram is 1,000 grams. And then we can take this 1 gallon of water, and luckily we actually did that in the last example, so you can go back and look at that, or if you want to do it again, you can. So after putting everything in the calculator and solving, we find that the heaviest is the 5-kilogram bag of sugar, and then comes the gallon of water, then the 5-pound bag of potatoes. So notice that this required us to use dimensional analysis and use these conversions, but then take it a step further by putting something in order. And then finally, the last example. So we have a 10 centimeter long cylindrical glass tube. So let's just kind of think about this. Okay, this is 10 centimeters long. Okay, it's sealed at one end, it's filled with ethanol. The mass of the ethanol needed to fill the tube is found to be 11.36 grams. The density of ethanol is 0.789 grams per milliliter. Calculate the inner diameter of the tube in centimeters. So now we have to figure out what in the world this question is trying to say. We know that we need the inner diameter. Diameter is straight across. So we know that we need diameter, which, think about geometry, is the same as 2r. So let's think about what we can maybe find from this information. Okay, we know the length. Let's look at what they gave us in terms of the ethanol, right? So they gave us the mass of the ethanol, how much we would need to fill it, and what the density is. So maybe there's something that we could solve for out of these two numbers. They gave us density, they gave us mass. What could we solve for? And well, we could solve for the volume. Let's take our mass, divide it by our density. Right, don't forget how to correctly solve for x here. And we get 14.39 milliliters. Okay, now remember, milliliters is the same as what? Centimeters cubed. So we have our volume, right? We now know this is the volume of ethanol that can fill this tube, which means the volume of the tube is equal to 14.398 centimeters cubed. Notice I'm not rounding because we're not done yet. So now we have the volume, we're trying to figure out diameter. Well, think about how you find the volume of a cylinder. Okay, well, finding the volume of a cylinder is pi r squared h. Think about what we have here, what we could find. Okay, well, we know the height. Okay, so now we know the volume. Okay, pi is always pi. R is what we're going to be looking for, and h is 10. So now we can solve. We can do 14.398 divided by 10 times 3.14. Okay, and so we can solve for r squared. Alright, so don't forget that's solving for r squared. I got 0.458. So depending on if you use 3.14 or if you actually use pi, you might get something a little bit different. And then take the square root. R is equal to 0.677 centimeters. Now, we need diameter. How do you figure out diameter? Multiply that by 2. When you multiply that by 2, you get 1.35 centimeters. 3 significant figures because our height was given in 3 significant figures. So notice you have to apply. That's what this class is all about, applying. And so, make sure, look through other examples. Read all the examples in the book if you need to. They give you a lot of great resources. Make sure you read the chapter. Ask me any questions. Send me emails with questions if you have them. But make sure that you understand this material because you're going to be using it all year long.